Page 14 of Euler's complex numbers, chapter 16 of MHL. Solve the following and display the roots on an Argand diagram. Okay, so these are pretty straightforward, right? First thing we're going to do is we're going to rewrite the complex number on the right as in cis theta form. So if we have 2 to the right and 2 up, that's a 45-degree triangle. So we would convert the hypotenuse from the legs of 2. It would be 2 square root of 2 would be the modulus. And the cis would be 45 degrees, pi over 4. And it would be pi over 4 plus 2 pi k, right? And then we can take the cube root of both sides, would give us z equals cube root of 2 square root of 2 is, let's see, that's 2 to the 3 halves cube root. And then the cube root for the cis would appear as pi over 12 plus 2/3 pi k. And obviously, since it's a cube root, there would be 3 different solutions. So it would be 2 to the 3 halves to the 1/3 would be 2 to the, we'd multiply these together, we get 2 to the 1/2. So z would be equal to square root of 2. And one of the solutions would be cis pi over 12. And then another one would be square root of 2 cis pi over 12 plus 2/3 pi. And so it'd be square root of 2 cis. And so 2/3 pi is the same thing as 8/12 pi. So it would be 9/12 pi. And 9/12 pi is the same thing as 3/4 pi. So square root of 2 cis 3/4 pi. And last of all, it would be square root of 2 cis pi over 12 plus 2 times 2/3 pi, which would be 4/3 pi. And that would be equal to square root of 2 times cis. Let's see, 4/3 is the same thing as 16/12. So that would be 17/12 pi would be the third solution. And let me shrink this down, and then we'll draw an Argand diagram for this. Okay, so there's the axes, and let's draw the first one, which is angle pi over 12. That would be, if you divide this into 6 sections, it would be the first section. Maybe a little bit bigger than that. It would be about here. The radius of the circle is square root of 2, right? The next one is going to be 45 degrees in this direction because it's 3/4 pi. And the last one is going to be 17/12 pi. 12/12 pi would be 180 degrees, then 5/12 pi would be 1/6 from there, right? So that looks about right. Okay. The radius of that circle is square root of 2. Okay. Let's do this one. Z squared equals 1/2 plus square root of 3 divided by 2 I. So this looks kind of like that. Okay, it's a 30, 60, 90 triangle. So if we were going to write this into cis theta form, we would say that the hypotenuse is 1. And our cis argument is going to be pi over 3. Z squared equals pi over 3. And then we'll take this, and then we'll write here plus 2 pi k. And then we'll take the square root and we'll get z equals cis pi, and then instead of pi over 3, it would be pi over 3 divided by 2, so it would be pi over 6, plus, divided by 2, it would be plus k pi. And there's only two solutions here because it's a square root. So the first solution is going to be pi over k, or pi over 6, sorry. And the next one is going to be pi over 6 plus pi, which would be 7/6 pi. So 1/6 pi would be 30 degrees, and 7/6 pi would be 30 degrees from there. All right? And the radius of this circle is 1. E. So let's start out with expressing that as a cis theta form. So it'd be -4, -4. So that would be 4 square root of 2. And the angle would be -3/4 pi plus 2 pi k. And if we take the fifth root of both sides, we get z equals 4 square root of 2 is 2 to the 2 squared plus 1/2, which would be 2.5, which is 2 to the 5 halves. And then we're going to take the fifth root of that. And then the cis, we're going to take the fifth root of the cis, which means we're going to divide everything by 5. Like that. So the modulus is going to be 2 to the 1/2. And the cis values, the first one's going to be -3/20 pi. And I'm going to rewrite square root of 2, or 2 to the 1/2 is square root of 2. And then there's going to be 5 of these values. So, and then the next one's going to be -3/20 pi plus, instead of 2/5, I'm going to write it in terms of 20. So it'll be, instead of 2/5, it'll be 20 on the bottom, and it'll be 8 on top. 2/5 is 8/20. So my next value is going to be 5/20 pi, because 8/20 pi plus -3/20 pi is 5/20 pi, which is equal to square root of 2 cis pi over 4. The next one would be -3/20 pi plus 16/20 pi, with k equals 2. So that would be 13/20 pi. And then the next one's going to be square root of 2 cis. In this case, it'll be, we did 0, we did 1, we did 2, now we're going to do 3. So 3 times 8 is 24 pi over 20. 24 minus 3 is 21, so 21 pi. Oops. 21/20 pi. That would be the fourth. And the fifth would be 29/20 pi. Okay, so if we were going to draw this argand diagram, so the first one would be -3/20. So that's pretty hard to draw. So if we divide each 180-degree part into 20 sections, each quarter circle is going to be 10 sections. So -3/20 would be about 30% of this 30%. So that would be more like this, right? So this would be -3/20 pi. And then the radius of the circle is square root of 2, of course. Then the next one's going to be cosine pi over 4. That would be here. Then 13/20 pi would be about 30% of this circle. And then 21/20 pi would be about 10% of that. And 29/20 would be like that. So, and the modulus, again, is square root of 2. Okay, 7. Find the four solutions of z to the fourth plus 1 equals 0 in the form a plus bi and display them on an argand diagram. Okay. By the way, yeah, we didn't need to find it in a plus bi form, thank goodness. So z to the fourth plus 1 equals 0 is actually equal to z to the fourth equals -1, right? -1 can be written in cis theta form as 1 cis 180 degrees, or cis pi. We could rewrite, instead of pi, we could write pi plus 2 pi k, because any multiple of 2 pi added on would be the same angle. Then we could take the fourth root of both sides. Then we'll have z equals, fourth root of 1 is just 1. Fourth root of cis pi plus 2 pi k is cis pi divided by 4 plus 2 divided by 4, which is 1/2. But we'll write 2/4 because it makes it easier to add to pi over 4, pi k. And then we'll find all the roots. So one of the roots is going to be cis pi over 4 when k equals 0. When k equals 1, it'll be pi over 4 plus 2/4 pi, which will be cis 3/4 pi. And the third root would be cis pi over 4 plus 4/4 pi. So that would be 5/4 pi. And the fourth root would be cis 7/4 pi. And that would be the last root, right? Now it says to put it in a plus bi form. So cis pi over 4 would be, let's see, what's the modulus of this? It would be 1, right? So if you had a triangle of hypotenuse 1, where the angle is pi over 4, then this would be 1 over square root of 2, and this would be 1 over square root of 2. So you could put 1 over square root of 2 cis pi over 4, no, I'm sorry, 1 over square root of 2 plus I times 1 over square root of 2. If it's 3/4 pi, it would be a triangle pointing in that direction, so it would be -1 over square root of 2 plus I times 1 over square root of 2. If it's 5/4 pi, it would be a triangle in this direction, so it would be -1 over square root of 2 minus I times 1 over square root of 2. 7/4 pi would be a triangle in that direction, so it would be +1 over square root of 2 minus I times 1 over square root of 2. Okay? All right, B. Hence write z to the fourth plus 1 as a product of two real quadratic factors. So we do need to display them on an argand diagram. And when we do this, the radius of the circle is 1. It's going to look like this with all the roots at 45 degrees angles from the vertical and the horizontal. Now, let's figure out what the two real quadratics are going to be. So the way we can do that is we can pair our complex roots up in conjugate pairs. And if we do, then they will make quadratics with real coefficients. So like this root and this root would be a conjugate pair, right? Because they reflect about the x-axis. So that would be pi over 4 and 7/4 pi. And then 3/4 pi and 5/4 pi would also be conjugate pairs. So let's try, let's see, if we want to find the conjugate pair, or the real polynomial that's generated from cis pi over 4 and cis 7/4 pi, we can find that by multiplying these two factors together. And if we do, remember that this would be the multiplication of the two numbers. And then we can also sum the two numbers, and that would give us the middle term, the b term, the negative of the b term. So let's do that. We're going to multiply cis pi over 4 together with cis 7/4 pi. And if we multiply those two together, product, we're going to get cis 8/4 pi. 8/4 pi, which is cis 2 pi, which is equal to 1. Okay, and if we add cis pi over 4 and cis 7/4 pi, that is going to cancel out the imaginary parts of the two. And basically what we're going to do is we're going to add 1 square root of 2 with 1 square root of 2. And so the sum would give us 2 over square root of 2. And if we were going to put this into a real polynomial, it would turn out to be x squared minus 2 square root of 2. This is the 2 square root of 2, goes right there. X plus 1. And of course we could simplify the b term into square root of 2. Right? Just one thing, these are z's. Let's make them z's. Okay. Next, let's do the other conjugate pair. So the other conjugate pair would be, instead of pi over 4 and 7/4 pi, it would be 3/4 pi and 5/4 pi. So if we have cis 3/4 pi and we have x minus cis 5/4 pi, and we multiplied and added these together, when we multiply them together, we'll get cis 8/4 pi, which is equal to 1. And if that's a product. And if we add them, then since they're complex conjugates, the imaginary parts cancel, and we just end up adding negative 1 over square root of 2 and minus 1 over square root of 2, which gives us negative 2 over square root of 2, which is negative square root of 2. So the b term is going to be negative square root of 2, so it'll be positive square root of 2, z plus 1. And so let's express it as two real quadratics multiplied times each other. It would be this quadratic times this quadratic. Okay? All right, number 8. Consider Z equals this huge mess. Using polar form and de Moivre's theorem, find the modulus and argument of Z. Okay, let's see. First, I'm going to rewrite this in cis form. So the top is going to be, let's see, square root of 3 over 2 is to the right, and negative 1/2 is down. So that's a 30, 60, 90 triangle. It's negative 30 degrees. So it would be cis negative pi over 6 squared. And the bottom is going to be cis, it's pi over 10 to the cosine pi over 10 to the right, and negative sine pi over 10 down. So that would be the same as negative pi over 10 cis. And so that's to the 5th power. And then this other one is just a straight up cis pi over 30th to the 25th power. Okay. Now does that look a little bit better? So all we need to do with these roots is to multiply them times what's inside. So the cis negative pi over 6 becomes cis negative 2 pi over 6, because we just multiply the inside by the squared, the 2. And then the cis negative pi over 10 becomes cis negative 5 pi over 10. And then the cis pi over 30 to the 25th becomes cis 25 pi over 30th. Okay, and then so the top becomes cis negative pi over 3. And the bottom becomes cis negative pi over 2. And then cis, and then this is 5, 6 pi. And I can combine the bottom two cis's, because if I multiply two cis's together, I add the arguments. So the bottom becomes, so negative pi over 2 is the same thing as negative 3, 6 pi plus 5, 6 pi, which would give me 2, 6 pi, which would be positive pi over 3. And the top is negative pi over 3. So now I'm going to combine the top and the bottom here. Whenever you have cis's dividing each other, you subtract the arguments. So the result would be cis negative pi over 3 minus pi over 3. So the result here would be cis negative 2/3 pi. So the modulus here is equal to 1, and the argument here is equal to negative 2/3 pi.